On March 17, 2024, at 2:32 p.m. Coordinated Universal Time, 140 million miles from Earth, something impossible appeared on a radar screen that would force humanity to rewrite everything we thought we knew about our place in the solar system. The signal came from 180 meters beneath the Martian surface, in a region called Noctis Labyrinthus, -7.8 degrees south, 259.4 degrees east. The impossibility was immediate and undeniable. A perfectly rectangular structure, 2.4 kilometers in length, with interior angles measuring exactly 90 degrees. Natural geological processes cannot create 90-degree angles at that scale. Erosion doesn't work in straight lines. Tectonic activity doesn't produce urban grids. But that's what the data showed. Blake had been analyzing ground-penetrating radar returns from the Perseverance rover for 6 hours that day, running the RIMFAX instrument through its standard sweeps of the Canyon system. He was a NASA geologist with 12 years of experience, formerly stationed in Antarctica mapping subglacial lake systems, a man trained to recognize the difference between natural formations and human-made structures buried under ice. The skills translated to Mars. He knew what bedrock looked like on radar. He knew what lava tubes looked like. He knew what collapsed channels and ancient riverbeds looked like. This was none of those things. The radar return showed a structure with walls of consistent thickness, internal chambers arranged in geometric patterns, and a material density matching processed basalt, not natural volcanic rock. The frequency response was wrong. The reflection coefficients were wrong. Everything about it screamed artificial construction. Blake ran the scan 3 more times. Same result. He adjusted the frequency range from 150 to 1200 megahertz, cycling through the full RIMFAX spectrum. The structure remained sharp and clear, like an architect's blueprint rendered in radar waves. He checked the rover's positioning system. Coordinates confirmed. He checked the instrument calibration logs. No errors, no anomalies. The equipment was functioning perfectly, which made what he was seeing significantly worse, because it meant the structure was real. He pulled up the geological survey data for Noctis Labyrinthus, cross-referencing the depth measurements with known stratigraphy. The rock layers above the structure dated to the late Noachian period, approximately 1.8 billion years ago. Whatever this thing was, it had been buried for nearly 2 billion years, long before the first multicellular organisms appeared on Earth, long before anything on our planet could build anything more complex than a bacterial mat. Blake reached for the communication panel to file his report to Mission Control at the Jet Propulsion Laboratory in Pasadena, California. His hand was halfway to the keyboard when every screen in his workstation went dark. Not a gradual shutdown. Instantaneous blackout. The communication link indicator showed red. The data stream from Perseverance had stopped. The timestamp on his monitor read 2:36 p.m. UTC, 4 minutes after the initial detection. 4 minutes for someone, somewhere, to notice what he'd found and decide he shouldn't be looking at it. The official notification appeared on his secondary monitor, the one connected to the internal NASA network, not the rover systems. Scheduled calibration maintenance in progress. Data stream temporarily interrupted. Expected duration, 48 hours. Blake stared at the message. He'd worked Mars missions for 8 years. Calibration didn't happen during active operations. Calibration was scheduled weeks in advance, coordinated across 3 shifts of engineers, announced in daily briefings. There had been no announcement. The telemetry logs he'd reviewed that morning showed all systems operating at 98% efficiency. There was nothing to calibrate. But there was something to hide. He looked at his workstation screens, all blank except for the maintenance notification. Then he looked at the small external drive connected to his personal laptop, sitting 6 inches from the dead NASA terminal. The drive he used for backing up his own research notes, the drive that ran on a separate power supply, the drive that had been recording every bit of data from his session for the past 6 hours, including 73 seconds of RIMFAX returns showing a 2.4-kilometer artificial structure buried beneath the oldest terrain on Mars. Someone had cut his access to the data, but they didn't know he'd already saved it. 6 months earlier, Blake had sat in a briefing room at the Jet Propulsion Laboratory in Pasadena, watching Carter, the chief planetary geologist, trace his finger across a topographical map of Noctis Labyrinthus projected on the wall. Carter was 53 years old, a veteran of 4 Mars missions, a man who spoke about ancient riverbeds the way archaeologists spoke about lost cities. This region, Carter had said, tapping the screen where a maze of collapsed canyons cut through the Martian highlands, represents our best window into the planet's tectonic past. We're looking at fault systems that were active 3.7 billion years ago, when Mars still had a magnetic field, when liquid water carved these valleys. Your job is to map the subsurface structure, document any remaining hydrothermal systems, help us understand what Mars was like when it was alive. Blake had nodded, taking notes, not knowing that 6 months later he'd be mapping something that had nothing to do with water or volcanism, something that would make every assumption in that briefing obsolete. The memory dissolved as Blake ejected the external drive from his laptop, the small click of the mechanism pulling him back to the present, to his darkened workstation, and the growing certainty that he'd just documented something someone very powerful wanted to remain buried. He couldn't file an official report, not with communications locked down, not with his access revoked. But he could do what scientists had done for centuries when institutions failed them: share the data with peers and let independent analysis determine the truth. He pulled up his personal email, the account that ran through his phone's network, not NASA's servers, and attached the 73 seconds of RIMFAX data to a message addressed to Wyatt Chen, a planetary scientist he'd met at a conference in Boulder 3 years ago. Wyatt had left the European Space Agency after publishing 47 peer-reviewed papers on Martian geology, choosing independence over institutional constraints, choosing questions over answers predetermined by funding committees. If anyone could confirm what Blake was seeing without agenda or filter, it was Wyatt. The reply came 11 hours later, at 1:47 a.m., while Blake was lying awake in his apartment in Pasadena, staring at the ceiling and wondering if he'd just ended his career. The email was brief. "Call me. Now." Encrypted line. Blake grabbed his phone, opened the secure app they'd used to share preliminary research before, and waited through 3 rings before Wyatt's voice came through, sharp and urgent despite the late hour. "I've run the data through 6 different analysis programs," Wyatt said. "No greeting, no pleasantries. Spectral decomposition, electromagnetic modeling, synthetic aperture comparison with known geological formations. Blake, this isn't basalt. The radar signature shows a material composition that doesn't exist in any meteorite database. We're looking at a metallic alloy with isotope ratios that don't match anything from the solar system's formation. Someone made this. Someone processed raw materials, created an alloy, and built a structure 2.4 kilometers long." There was a pause, the sound of Wyatt breathing on the other end of the encrypted connection. The rock layers above it date to 1.8 billion years ago. "Do you understand what that means? This thing was built before complex life existed on Earth, before anything on our planet could use tools or fire or language. Mars had a civilization when Earth had algae. Blake closed his eyes, feeling the implications spread through his mind like cracks in ice. He thought about the pyramids of Giza, 4,500 years old, and considered ancient. He thought about Göbekli Tepe in Turkey, 11,600 years old, and celebrated as humanity's oldest temple. He thought about the first stone tools, 3.3 million years old, the earliest evidence of intelligence shaping matter. None of it came close. This structure on Mars predated human evolution by nearly 2 billion years. It predated dinosaurs by 1.7 billion years. It existed in a time when Earth's atmosphere was still toxic, when our sun was 30% dimmer, when the Milky Way itself was in a different configuration. "I need a third opinion," Blake said, his voice steady despite the weight of what he was holding. "Someone who specializes in ground-penetrating radar. Someone who can't be dismissed as a conspiracy theorist or attention seeker." Wyatt didn't hesitate. "Harper Reeves, University of Arizona. She wrote the textbook on planetary radar interpretation. I'll send her the data with your permission. No names attached, just the raw numbers. If she confirms what we're seeing—" He trailed off, leaving the sentence unfinished, because they both knew what confirmation meant. It meant humanity wasn't first. It meant intelligence in the solar system predated us by eons. It meant Mars had been home to something that built cities while Earth was still a hostile, lifeless rock. Harper's response came back in 16 hours, a detailed technical analysis followed by a single sentence that Blake would remember for the rest of his life. "Whoever built this understood engineering at a level we're only beginning to approach. This wasn't built by accident. This was built by something that knew exactly what it was doing." The email from Dalton arrived at 7:03 a.m. the next morning, marked urgent, the subject line reading simply, "Cease unauthorized analysis immediately." Blake opened it in his kitchen, coffee cooling in his hand, and read the 3 terse paragraphs that made it clear someone had been monitoring his communications despite the encrypted apps, despite the personal devices, despite every precaution he'd taken. "You are hereby ordered to discontinue all independent analysis of RIMFAX data from Sols 412 through 415, the message read, using the official Martian day count to pinpoint exactly which scans Blake had been studying. All related data files are to be transferred to the Office of Planetary Protection within 24 hours. You are not authorized to discuss, share, or publish any findings from this data set. A classified briefing has been scheduled for senior mission personnel. Your attendance is not required." Blake read that last sentence twice, feeling the weight of what it meant. In 12 years with NASA, he'd never been excluded from a briefing about data he'd personally collected. The message was clear. He'd seen something he wasn't supposed to see, and now he was being quietly removed from the conversation. He was staring at the screen, weighing his options, when his phone buzzed with a notification from an encrypted file-sharing service he'd used once, 2 years ago, during a joint research project with the European Space Agency. The sender was listed as N. Volkov, and Blake's memory took 3 seconds to place the name. Nadia Volkov, a Russian cosmonaut he'd met at an international planetary science symposium in Geneva. A woman who'd worked on data analysis for the Mars Express orbiter during the European Space Agency and Roscosmos collaboration missions. They'd exchanged maybe 20 words total, professional pleasantries, a brief discussion about subsurface ice detection methods. He had no idea why she'd be contacting him now through a service that guaranteed end-to-end encryption and left no server logs. He downloaded the file, entered the decryption key she'd included in the message, and watched his screen fill with orbital imagery from Mars Express, high-resolution radar maps of the Martian equatorial region, dated from 2019 through 2023. At first, Blake didn't understand what he was looking at. Then, Nadia's attached note made it clear, "You found one. Here are 14 more." The images showed subsurface anomalies at 14 different locations across Mars, all of them in the equatorial belt between 30 degrees north and 30 degrees south latitude, all of them at approximately the same depth, 170 to 190 meters below the surface. Each anomaly displayed the same characteristics Blake had seen in Noctis Labyrinthus: geometric precision, artificial material composition, structural integrity, inconsistent with natural formation. But what made Blake's hands start shaking as he zoomed in on each location wasn't just the confirmation that his discovery wasn't isolated, it was the pattern. He opened a mapping program, plotted all 15 sites, including his own, and measured the distances between them. The spacing wasn't random. Each structure was separated from its nearest neighbor by approximately 847 kilometers, with variations of less than 3%. That kind of precision across a planetary surface doesn't happen by chance. He ran the numbers through a geological modeling program, overlaying the structure locations with reconstructions of Mars's ancient magnetic field, the network of lines that would have existed 4 billion years ago when the planet still had a molten core and active dynamo. The structures aligned perfectly with the magnetic field lines, as if whoever built them had used the planet's own electromagnetic framework as a navigation grid, as if they'd understood Martian geology at a level that let them work in harmony with forces humans were only beginning to map. Wyatt called at 9:15, his voice tight with the same realization Blake was processing. "I've been running population density models," Wyatt said. "If these 15 sites represent urban centers with the kind of infrastructure we're seeing in the radar returns, and if we assume construction patterns similar to human cities, we're looking at a total Martian population of approximately 150 million at the time these were active. That's not a colony. That's not an outpost. That's a civilization, a Type 2 civilization on the Kardashev scale, something that had mastered planetary engineering and resource extraction at a level we haven't reached yet." Blake heard the unspoken question in Wyatt's voice, the same question that was tearing through his own mind. What happened to them? A civilization that advanced doesn't just vanish. They had the technology to build cities that survived nearly 2 billion years of burial. They had the knowledge to space their settlements using magnetic field lines. They understood materials science, structural engineering, planetary geology. And yet, they were gone, buried under 180 meters of rock and dust, erased so thoroughly that humanity had been exploring Mars for 60 years without knowing they'd been there. Harper sent her analysis an hour later, and it made everything worse. She'd cross-referenced the subsurface structure data with atmospheric composition readings from the Curiosity rover, specifically a dataset from 2019 that had measured isotope ratios in the Martian air. There was an anomaly in the data that had been flagged and archived without explanation. An unusually high concentration of xenon-129, an isotope that exists in abundance only after nuclear explosions or massive asteroid impacts. The concentration was 0.3% higher than expected, distributed evenly across the planet's atmosphere, consistent with an event that had happened approximately 1.8 billion years ago, the same time frame when the cities were buried. "Here's what we're looking at," Harper wrote in her report, her normally careful academic language giving way to something more direct. "A planet-wide catastrophe. Either they destroyed themselves with weapons we can only theorize about, or something from outside the solar system hit them hard enough to sterilize the surface and bury every trace of their existence under meters of debris. Either way, they had all the advantages we think make a civilization safe. Advanced technology, planetary colonization, resource management, probably space travel. And it wasn't enough. They're gone. Which raises a question we need to ask ourselves. If Mars had a civilization that lasted millions of years and still went extinct, what does that say about our chances? Blake sat in his apartment, looking at the data spread across 3 monitors, thinking about the Great Filter, the theoretical barrier that prevents civilizations from reaching interstellar capability, the cosmic wall that every intelligent species supposedly hits. He'd always thought it was behind us, that humanity had already passed the hard steps, developing multicellular life, achieving intelligence, creating technology, avoiding nuclear war. But what if the filter wasn't behind us? What if it was ahead, waiting, the same obstacle that had stopped the Martians despite everything they'd built? What if advanced technology and planetary engineering and millions of years of development weren't enough to guarantee survival? The thought sat in his mind like ice, cold and heavy and impossible to ignore, because Mars had been where we were trying to go. And Mars had failed. Harper found it 3 days later, buried in the public archives of NASA's Planetary Data System, a photograph that had been sitting in plain sight for 48 years, catalogued, indexed, and completely ignored. She'd been searching through Viking 1 lander images from 1976, the first successful Mars surface mission, looking for any visual evidence that might correlate with the subsurface structures. Most of the photos showed exactly what the mission reports described: rust-colored rocks, wind-blown dunes, the occasional dust devil moving across Chrysoplanitia. But image number 21B47, taken during a dust storm on August 9, 1976, showed something different. In the lower right quadrant of the frame, partially exposed by wind erosion, there was a metallic object, approximately 2 meters in length, with what appeared to be geometric markings along its visible surface. The official catalog entry listed it as debris from lander, possible heat shield fragment. Harper had done the math in under 5 minutes. Viking 1 had landed 340 kilometers north of where this photo was taken. Heat shields don't travel 340 kilometers. She'd analyzed the shadows, calculated the sun angle, confirmed the object's position and scale. It wasn't debris from the lander. It was part of something larger, something buried, something with markings that looked deliberately carved rather than randomly weathered. When she sent the analysis to Blake and Wyatt, her message included a single question. If they've had this photo since 1976, what else do they have? The answer came from Carter, of all people, the man who'd briefed Blake 6 months ago about mapping ancient water systems, the man who was supposed to be focused on geology and hydrothermal activity. Carter called Blake directly, using his personal cell phone, not the NASA office line, his voice carrying a weight Blake had never heard before. "I need to show you something," Carter said. "Something I should have shown you months ago." They met at a coffee shop in Pasadena, far from JPL, far from anyone who might be listening, and Carter pulled out a tablet loaded with seismic data from the InSight lander, the mission that had operated on Mars from 2018 to 2022, measuring Marsquakes and mapping the planet's interior structure. "Look at these S-wave patterns from Elysium Planitia," Carter said, scrolling through waveforms that Blake had seen in published papers, data that was supposed to show natural geological activity. "We detected cavity signatures, empty spaces under the surface that shouldn't exist in solid bedrock. The official report called it a calibration anomaly. We archived it and moved on. Carter looked up from the tablet, and Blake saw something in his eyes that might have been shame or might have been fear. It wasn't an anomaly. It was chambers, artificial voids. We've known about them for 6 years, and we buried the data because we didn't know what to do with it. Blake felt something shift in his understanding, a fundamental reordering of what he thought he knew about the organization he'd worked for, the mission he'd believed in. "How long?" he asked, keeping his voice level despite the anger building in his chest. "How long has NASA known that Mars had a civilization?" Carter didn't answer immediately. He closed the tablet, looked around the coffee shop to make sure no one was close enough to hear, and then said the thing that changed everything. Since Mariner 9, 1971, the first orbital photographs with high enough resolution to show surface details. There were anomalies in the images, geometric patterns that didn't match natural geology. The data went to a classified analysis group, joint operation between NASA, the European Space Agency, Roscosmos, and later the China National Space Administration. We've been studying this for 53 years. Every major Mars mission since then has had a secondary objective: map the subsurface anomalies, determine their age, assess whether they pose any threat. See, Blake leaned back in his chair, processing what he was hearing, understanding now why his communications had been cut so quickly, why Dalton had excluded him from the briefing, why the response to his discovery had been so immediate and so coordinated. This wasn't a cover-up born from panic or confusion. This was institutional protocol, established decades ago, refined through years of practice. "Why?" Blake asked. "Why keep it secret? Why not tell people that we found evidence of extraterrestrial civilization? That's the biggest discovery in human history." Carter's expression hardened, and when he spoke, his voice carried the kind of certainty that came from years of classified briefings and security protocols. "Because we don't know what killed them. A civilization advanced enough to build cities across an entire planet, advanced enough to survive for millions of years, didn't just die from bad luck or poor planning. Something extinguished them. Something powerful enough to bury 15 major population centers under nearly 200 meters of debris in what appears to have been a simultaneous event. Until we know what that threat was and whether it's still active, the decision was made to keep the discovery classified under planetary security protocols. We're not hiding the existence of Martian civilization. We're hiding the fact that something out there is capable of destroying planetary civilizations, and we have no idea what it is or whether Earth is next on its list." Blake thought about the xenon 129 in the atmosphere, the isotope signature of catastrophic destruction. He thought about the structures buried at identical depths, the simultaneous nature of their entombment. He thought about all the assumptions humanity made about safety and progress and technological advancement, and how Mars proved that none of it guaranteed survival. "The Mars Sample Return Mission," he said slowly, pieces clicking into place. "The launch scheduled for 2028. That's not about collecting rocks for geological analysis, is it?" Carter shook his head. "Site Alpha, Noctis Labyrinthus. The structure you found. We're going to drill down, retrieve artifacts, try to understand what they knew and whether they saw it coming. Because if they didn't, if a civilization that advanced had no warning—" He didn't finish the sentence. He didn't need to. Blake understood perfectly. If Mars couldn't save itself, what made anyone think Earth would be any different? By August of 2024, 4 months after Blake's discovery, the Perseverance rover had been quietly redirected from its planned route through Jezero Crater to a new destination that didn't appear on any public mission timeline. Site Alpha, the structure beneath Noctis Labyrinthus, the 2.4-kilometer grid that had started everything. The official NASA feed showed the rover's cameras as offline for maintenance, a routine status that no one questioned because rover maintenance was common enough to be boring. But amateur astronomers with decent telescopes noticed something the public relations team hadn't anticipated. Dust plumes rising from coordinates that matched Noctis Labyrinthus exactly. The kind of plumes created by drilling operations, by machinery breaking through Martian regolith. The rover wasn't in maintenance. It was digging. Blake had been removed from the Mars program by then, reassigned to a desk position analyzing meteorite composition data, as far from active missions as NASA could place him without outright firing him. But before he left, he'd written a piece of code, elegant and simple, embedded in the rover's telemetry system, a timed transmission, 6 seconds long, that would bypass the normal communication protocols and send raw data directly to 3 email addresses: Wyatt's, Harper's, and Nadia's, on a date he'd chosen at random months in advance. The transmission activated on September 3rd at 11:22 p.m. Pacific Time, and in those 6 seconds, it sent enough information to confirm what everyone had suspected, but no one could prove. The telemetry showed Perseverance's current position, 40 meters inside the structure, having drilled through the surface layer and descended via what appeared to be a collapsed access tunnel. Internal temperature reading: negative 23 degrees Celsius, 47 degrees warmer than the Martian surface directly above. That temperature differential meant one thing: active heat source. Something down there was generating thermal energy nearly 2 billion years after the city had been buried. The atmospheric sensor detected pressure 0.3% higher than surface ambient, with trace amounts of methane showing organic molecular signatures, the kind produced by biological processes or extremely advanced synthetic chemistry, not by geological outgassing. The final piece of data was an image, low resolution, taken by the rover's hazard avoidance camera, showing a wall segment approximately 3 meters from the rover's position. The wall was covered in symbols, arranged in horizontal rows, each symbol roughly 10 centimeters in height. Most of them were unfamiliar, geometric patterns that could have been writing or decoration or mathematical notation. But one symbol, located in the upper right section of the visible wall, was different. It was a sequence of numbers: 6, equatorial mount coordinates, hydrogen line frequency. The exact same pattern that had been received at the Big Ear radio telescope in Ohio on August 15, 1977, the transmission known as the WOW signal, the strongest candidate for extraterrestrial communication ever detected. A signal that had come from the direction of Sagittarius and had never repeated. Someone had carved that signal into a wall on Mars 47 years before Blake was born, 47 years before humans detected it, as if they'd known it was coming, as if they'd been expecting it, or worse, as if they'd been warning whoever came after them. Nadia published her analysis in a peer-reviewed journal 3 weeks later, using a pseudonym but including enough verifiable data that other researchers could confirm her findings. Wyatt testified before a congressional subcommittee on space exploration transparency, presenting evidence of systematic classification of planetary discoveries. Harper continued mining the public archives, finding 6 more images from Viking, Mariner, and Mars Global Surveyor that showed surface anomalies consistent with buried structures. The scientific community didn't accept the claims immediately, but they didn't dismiss them either, because the data was too specific, too consistent, too carefully documented to be fabrication or error. What happened to Blake was harder to track. His NASA email was deactivated in October. His LinkedIn profile disappeared in November. His published papers on Martian geology were quietly removed from the agency's research database. His last public statement was an Instagram post from July, a photo taken by Perseverance showing the Martian sunset, the sky fading from butterscotch to slate, with a caption that read, "We are archaeologists now, not explorers." The account went dark after that. No one has heard from Blake since. The cities on Mars are real. The data confirms it. They're approximately 1.8 billion years old, built by a civilization that understood planetary engineering, that survived for millions of years, that had everything we think makes a species successful. And they're gone, buried under rock and dust and time, preserved in the frozen geology of a dead world. 80% of the mystery is solved. We know they existed. We know roughly when. We know they built on a massive scale. But 20% remains, the questions that matter most. What preserved thermal energy for 2 billion years? What does the organic methane signature mean? Why did they carve the wow signal into their walls? What were they trying to tell us? And perhaps most importantly, where is Blake? And what did he learn in those last weeks before he vanished from public record? We went to Mars looking for signs of ancient microbial life, simple organisms that might have existed in long-dried rivers. Instead, we found evidence that we are not the first civilization in this solar system. We are not the pioneers. We are the second attempt. And if Mars, with all its advantages, couldn't make it, the question we need to ask ourselves isn't whether we're alone in the universe. It's whether being second means we get a chance to learn from their mistakes, or whether some cosmic filter doesn't care how many times we try.